So click on open file.
Yes, sir.
It will take some time. Wait. Yeah. Now, yeah. Just okay. Next, 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 next. ಹೋಗ್ತಾ ಇಲ್ಲ ಅಲ್ಲ ಬ್ಯಾಕ್ ಅಲ್ಲ ನೆಕ್ಸ್ಟ್ ಏನು ಬೇಡ ನೆಕ್ಸ್ಟ್ So other participants who are having problems with their installation also can approach like this. I have enabled screen share. So if you have any specific problem in your computer, you can ask me. Yeah, finish.
Yes, sir.
Now you have installed Candy. You have installed R. Now you go back to R Studio. No. Minimize this. You can close the window. R we have already installed. R Studio, we are looking at R Studio.
Now I've come to the screen, sir. Sir?
Yeah.
I've come to the screen, so it is installed, sir.
You have installed.
Now it's
Just hold on.
so once I click on that R Studio, then yes.
Yeah. So it is installed. That's it. Nothing more.
Okay.
This is R Studio. Okay. Got it.
Thank you.
So any other participant who is having such problems can share their screen, and I'll be able to do that. Yeah. Guru Prasad, hello, Guru Prasad.
Yes, sir. Yes, sir.
Yeah. Are you there in the college or you are there in the home?
No, sir. I'm there in college, sir. Residency college.
College. Do you have a? Can you take a GPS photo of the screenshot for me? GPS tagged photo.
Okay, sir. 1 second. 1 second.
Let me share my screen.
Yes, sir. Yes, sir.
Only one child in my class who have got 100% also. The only one. Very good side, no need to worry. We are very lucky parents child like this. Because ತುಂಬಾ ಕಷ್ಟ ಯಾಕಂದ್ರೆ ಎಲ್ಲಾ ಕ್ಲಾಸ್ ಅಟೆಂಡ್ ಮಾಡಿ 100% ಅಟೆಂಡೆನ್ಸ್ ಮಾಡಿ ಎಲ್ಲ
I'll take, sir.
I'm just looking at whether my recording has stopped. Okay, one second. Yeah. Do you have on your screen is the list shown, in the sense list of people are showing? You have stopped sharing, right?
Yes, sir. I stopped sharing.
So the member photos are shown on your screen.
Sir, only I can find 4 names and including you, sir.
Yes.
Yes, sir. I can find like this. Everyone.
You are able to see?
Sir, I have put them everyone in box.
Yeah. You took a photo. You take a photo.
Yes, sir.
You take a photo and send it to my WhatsApp number.
Yes, sir. I'll send, sir. I'll send, sir.
Yeah. Okay. Yeah. So. Yeah, just hold on. I'm trying to ask some of the participants to join because so just give me some time, sir. I'll join back. If some emergency comes, I have to give a break and join back. Yeah. Oh, sorry for that. So let me post in the group that they have to join. Just give me two minutes. 2 minutes. Yes. So we're ready to go, and I am sharing my screen. So hope you are ready, Guru Prasad. Others, hope you are having your PC ready. Hello.
Yes, sir. This is ready.
So next thing that we have to do is, see, this is not our programming session. This is R for research. So R for research, I'll be uh, doing what is needed for doing a task. For example, first how to get a data into R. Okay, I'll not be discussing about file types. I will not be discussing anything. I have a data. I'll show you how to import that particular, how to get that data from the file to uh, R Studio. That's it. Then we'll start directly working on that. But traditionally, how we teach R programming is different. R programming is more elaborate than this. So I don't know if everyone has joined or not. I don't know what other participants are doing. Hello, Vijay Lakshmi, Nisha Kumari, Maria, Manju Sri, Fabio, Georgie, Kavita, yes. I don't know whether you are faculty or whether you are student, but please do pardon me that your participation is not so encouraging. At least you should give some kind of feedback in terms of response. And let me frankly tell you that if you have joined it for some kind of certificate, that is the worst thing to do. Okay? So I don't know whether you will be getting a certificate or not. Let me use that. Yes, sir. If I have to give a certificate, worst case, I will be giving to Guru Prasad, who is responding, and that's it. Worst case. I did not plan for any certificate. This is the session that was organized by Vipasa Madam so that you can benefit from this. Okay, that's it. Now, first and foremost thing is take 5 minutes of data of 5 minutes of time, and this is specifically, there is actually a quiz. I have prepared a quiz for this part of R, in the sense that you are really good. This is really hands-on and direct to the task. There is no no. Okay, my internet connection, is it fine? Checking the internet connection, because yeah, it should be fine. Karunakar, I think Karunakar has joined. Okay. Now, first thing, First things first, we'll get this quickly going and we'll end the session after this session. In a sense, instead of taking two parts, we'll finish this work and we'll end the session for the day. Now, yes, sir. This is RStudio. RStudio has 4 windows. Right now, what you are seeing only 3. If I maximize this, this is a 4. And the 4th one is not seen because I was trying to. Okay, now I have to restart. Environment reset. There will be some reset here. This is source, this is console. So these are the 4 windows. The first window that you are seeing on the left top is called as a source. The bottom window that you are seeing is called as a console. Yeah, first things first, hope you are able to see the screen. Let me know. Hello? Are you able to see the screen?
Yes, sir. Go ahead, sir.
Yeah. So I am trying to discuss about the components of your RStudio. So their names, you can find the names here. Their names here, you can see source. This is the source pane. And this is the console. What you are seeing on the bottom is console. On to your right side, what you are seeing, the right top, top right is your file plot. No, this is history and other things, not file plot. So environment history. So here you will have environment history, then connection, you will have connection, and down bottom you will have files, plot, packages, help, so on and so forth. Okay. So now, so yeah, so this is how your default view will be. So let me explain what is source. Source is where you can write the program, and the console is where this is R. When we say RStudio, what is R part is this is R part. Okay. I have R installed. First we had installed R. Okay. So in R, there is something called as R console. Here I type something. Let us say 5 plus 5, getting the answer. So I'm typing the command, immediately getting the answer here itself. It is okay if you are using one line of command, then it is okay. I can type in the console itself. I can type the input, press enter, I get the output. But if I have to run many lines at a time, if I have many lines and I have to execute all of them at a time, then what I have to do is I have to write it and save it as a program. So how to write it and save it as a program? So we have something called a script window. If I say file, new file, R script, if you don't see this window, script window, you can say file, new file, and R script. This is where you write entire program. And once you execute that program, ultimately that program will come to console. Console is where that is the ultimate destination. The ultimate destination or the output of the program will have to come in console. Whereas there are 2 ways of running the program. Let me write my first program hash. If I say hash, that is a comment that will not run. So this is the comment. Then I am trying to print something called hello world. These are the 2 lines of my program. Now Control L will clear the console. Once I click on Control L, clear the console. So here I can execute these separately in the console only. If I execute a comment, nothing is coming out. Okay. Whereas if I execute a command, print hello world, it is printing hello world here. So The first line did not take. Okay, sir. Yeah. So that was Navneet.
Sorry, sir. Sorry, by miss.
Yeah,
happened.
but I can understand. So in console, you can see that I can directly type in console and execute comment. Anything that starts with hash is a comment, and the output is it doesn't give any output because it is for your reference, nothing. Whenever a command is given, the output of the command is coming here. If I say 5 plus 5, it gives me the output there. So this is about console in console. But whereas if I am talking about the source, in source I can write 3 lines at a time. Not only write but also save it for later use. If I click this floppy button, I can type and I can save this code and reuse it next time. Let me save it as first. I can save it for the next time also I can use, and I can save if I am using source file. Now let me in console I can execute only one line at a time. In source I can execute multiple lines at a time. For example, I have 3 lines here, and if I click source with echo, you can see what it has done is it has run all the 3 lines at a time, and the output is given here. But here not only the output, the input also is shown here. First program, print hello world is the input, the output, 5 plus 5 input, output. Sometimes you don't want both of them to happen, so you say source with just source, and it will without echo it will give me the output, it doesn't give the input. So what I'm trying to tell you is the source window is where you write only the code, and this code can either come in the console or the output also can come in the console. So I have shown you here. If I want to execute one line at a time, click on the anywhere in that line, press Control Enter. You can see the first line executed. Okay. Now third line is executed. So like this, I can either, if I want all of them, select all of them, press Control Enter. All of them are executed. So ultimately, console is the heart of. This is the engine of RStudio. And the first window is the script window, where you write a program and run. You can also write the code in console also. Next is your environment. Environment shows you what are the variables you have created in R and what do they contain. For example, let me create a variable. A variable is created, for example, X. Let us store a variable value X, value 10 into X, X is equal to 10, and you have a variable here. This is X is equal to 10. And you can see in the environment the variable that is created is shown here. Next thing that I have to discuss is something called as packages. We have seen installing software. Next we'll see how to install packages. One of the packages that I recommend you installing right now is ggplot2. So you click ggplot2, click on that, click install, and it will automatically get installed. Once it is installed, in the packages tab, if you type ggplot2, it will show in the packages, it will show ggplot. Second thing in the packages, what are the packages that are there in your system right now installed? All these you can scroll and see. If you want additional packages, click on install and install it. If you want to update these packages, you can click on update. If you want to delete any of these packages, you can click on X mark and delete the package. Second thing that you see here is there is a check mark on some of these packages and there is no check mark on other packages. What is this check mark? This check mark means that package is already loaded into the environment and it is ready to use. If there is no check mark, that means you have to load it into the library. For example, ggplot, normally any package that you install additionally will not be loaded. You have to load it by clicking here. You have to load it. For example, I click ggplot to movies and it executes a command and it is loaded. Now anything that is there in the package will contain your functions and data. I can use it. Okay. So this is about RStudio. And then one more thing, that any help that you want. For example, what is this ggplot sir is talking about? It is ggplot package. You can search for the help here. It will give any kind of help. For example, print function. Sir has talked about print function. What is this print function? So here is your print function. The entire, you don't need any book. This help file will contain everything that you need. Next thing is plot. Plot is where your graph will appear. Anywhere you draw the chart, okay, it will appear here. So here we have, right now we have a small chart. You can zoom into that chart. And this is your chart. So plot is where your plot will appear. Okay. So this is about introduction to the RStudio interface. Now let us get to our real work. I have provided a data file called, let us look at some data files. R has inbuilt data files. If you type data, press enter, you can see that these are the files that are already there in R. Air passengers is a data set. You type air passengers, press enter, you'll see the data. These are called as built-in data sets that you can use. Apart from that, you can import from outside. For example, I have provided a data set for you to import. So how to import that data set? What is that? Some pollution data set or something. So I am checking for the data set. I don't know where I have kept that. So just give a moment. Yesterday I had downloaded. Yes, sir. It seems to be there. Uh, yeah. So are you able to see my screen? Hello?
Yes, sir.
Yeah. So there is a file here called avgpm25. I don't know if it is the same file that I have sent a link to you. Did I send a link to you yesterday? Yeah, I think I had sent a link to you.
You have sent the data link, sir.
Okay. Yeah. So actually, the data that is provided to you is it's still more detailed. It is a zip file. What you have got is a zip file. Let me see if the link is there with me. I'm trying to see if the link is there with me. Yeah, it seems to be there. So let me open. So first thing, we are getting data. First I'm trying to get the data, then I'll describe the data, then we'll do something on the data. So how to download the data? Type the link that I have given, press enter, and your data AVG PM25 data is downloaded. Go to the download. This is a zip file. You extract this zip file. So here you see the zip file is extracted, and three things are there. First thing is a CSV file, Excel file, and the PDF. PDF file contains the description, detailed in-depth description about the data is given in the PDF file. And that same data is there in CSV, same data is there in Excel file. So let us see how to get this data into, what is this? Let me briefly describe. Open Excel file or CSV file. Anything will open in Excel. Either of them will open in Excel. So this is the data. The data is about pollution levels. First thing is PM25 is the pollution, amount of pollution. PM25 is particulate matter, 2.5 particulate matter. That is amount of pollution in the air. Higher the number, higher the pollution. Larger the pollution. FIPS is the region code. For example, we have a PIN code. So FIPS is like a PIN code of the region. For example, instead of writing Bangalore, I write 5600-571 Bangalore. So like that, I have region, the specific region, Bangalore PIN code I have. Next, Bangalore belongs to South. So I have South like that. Next, exact latitude and longitude point of the location. So this is the code of the location. You can say, I'm not really sure what exactly it means. You have the data, you can just read. I'm assuming that it is, first thing is it is a categorical way. It is like your roll number only. So what exactly this roll number is, so you can refer to this file and okay, I'm not sure. Okay, we'll check. Let us assume right now it is irrelevant. It is a categorical variable, that's for sure. It is a kind of pin code kind of thing. That I'm not sure whether it is exactly pin code or nearer to identification like your roll number and pin code. I'm not sure. But this is a categorical variable, identifying variable. Whether it is identifying the region or pollution sample area, I'm not sure. Okay, but it is kind of identification for it, for something. It is categorical variable. So this is the data, latitude, longitude, region, the identification of that particular area, and you have the pollution level, PM25 pollution level. Now let us start. First, we need to get this data into RStudio. That is the first thing that we'll do. Open RStudio, go to import dataset, and click from Excel because there is an Excel file. If you want to import from CSV, you can click at any other of them. So because we have Excel, let us click on that Excel file, browse, downloads. I have downloaded here. AVG PM25 open. Now here importing options, first thing is the variable name into which you are importing. I am importing this into a variable name pollution. Pollution is the variable name. So this is the only thing that I have to do. I have to change the variable name. I don't want AVG PM25. Ultimately, it is the amount of pollution. So I am directly using more sensible thing pollution. Come down here and click on import. Don't do anything with the rest of them. Import. Now after importing, in the environment you see the variable pollution and you see the data preview here after getting imported. Okay. So this is after getting imported. This is how it looks like. Next. So first thing that we have done is we have imported the data. Second thing is we'll be doing simple summaries of data. First thing is 5-number summary. So how to do 5-number summary? Let us look at that first. You can type anywhere. First, how to look at the data. There are different ways of looking at the data. If I say view of pollution, press Control Enter. Right now, the pollution data is open. This is one way of looking at pollution data. Or in the console, I can type view pollution, or just I can type pollution, press Enter. You can see that it is displaying the data in console. So this is how you view the data. Next thing is how to view the structure of the data or metadata. If I type structure of pollution, then you can see that it is a table. Table is a kind of tabular data. It is a tabular data. It contains 576 rows, 5 columns. What are the 5 columns? PM25, FIPS, region, and longitude, latitude. What is the dollar sign mean? Dollar sign means that using pollution dollar PM25, you can access this data. First column you can access. If I want to access first column, I say pollution dollar PM25. This is the first variable data. Okay. There is total 576 rows of data are there. So this is how I access individual data. But before accessing individual data, if I want to see the preview of data, only some part of the data, first few lines of the data. If I say head of pollution, then I can, it doesn't display all the variables, it displays only first 6 variables it will display. So that, because if it is a large data set, it will be sometimes difficult to see. It will go down the long screen. So we say head of pollution to see the data, to view the data. Next, so these are different ways of viewing that data and metadata. The next thing that we are trying to perform is a summary. So type summary of pollution. So if I type summary of pollution, for each variable, I am getting minimum, first quartile, median, mean, third quartile, max. If you can see that this is what I have discussed with the box plot. 5-number summary in visual is the box plot. In box plot, lowest line is your minimum. Let us discuss about that also. Okay. So here, when I say pollution, summary of pollution, it is giving me the summary for each variable. PM25 is a variable, FIPS is a variable, region is a variable, longitude is a variable, latitude is a variable. For all these variables, it is giving me the summary. Next, let us. Next thing is, how can I access single variable? I can access single variable, for example, pollution. If I type dollar, all these are the fields that are there in this. So PM25 will give me the pollution data control center. Otherwise, enter only here. Here, if it is, I'm giving you the console, it is just enter. So this is how I look at PM25. Next, I want to look at summary of pollution 25, pollution dollar PM25. This will only give me the summary of pollution data, that is minimum first quartile. So if I say box plot of pollution dollar 25, okay, okay, so, sorry, I have to type the same thing. Pollution dollar PM25 is available. Yeah. So let me repeat again. So if I say summary of the variable, it is giving me minimum first quartile, median, mean, third quartile, maximum. Now let us look at this data. Zoom in. So, so you can see the minimum is 3.83. So somewhere here, this is the minimum. First quartile is 8.59. So that comes to, this one is first quartile 8.59. What does this mean? 3.83 and 8.59. What does minimum 3.83 first quartile 8.59 mean? That 25% of regions, 25% of the regions we have, what is it? In STR, if we want to see how many rows of data are there, we say n row of pollution 576. So 576 areas I have taken and 576 area of pollution I have got. So this pollution data is here. This is the data 576. I am categorizing these 576 into what is it? Into a summary plot, and I have got the minimum as so this is minimum is the first one. Sorry, this is the minimum. So minimum is 3.83 and maximum is 8.549, and you have medium as 10.049, and you have this is the first quartile, that means 25% of the data is here, 50% of the data is here, another 25% is here, another 25% is here. So first quartile is at 88.549. So how to interpret that is 25% of the out of 576 regions pollution data, 25% of 576, 25% of 576 means 0.25 into 576, 144 region. So what we are telling is 144 regions, 144 regions have their pollution levels under 8.549. 8.549 PM25 is their pollution level. Next, median 10.049. That means average pollution, on an average 10.047 is the pollution. Median is one type of average, mean is another type of average. So what does median mean? The median tells us that out of 576, 288 cities have pollution levels under 10.047 PM25. Next, third quartile. We'll not discuss about mean right now because we are comparing with the box plot. And third quartile is the upper part of the box here. So third quartile means 75% of the data. So we say 75% of the data is 0.75 into 576. So we say 432 cities pollution levels. So 432 cities have their pollution levels under 11.356, and 100% of the cities are there under 18.441. So this is how you have to read the 5-number summary. One extra thing that is there here is 9.836, which is mean, which is arithmetic mean. Arithmetic average is different from second quartile median, that you already know. I will not describe that. So this is summary. So similar to summary, we have another command called quantile or quartile. Quantile. If I say quantile of pollution $PM25, you can see here, instead of if I say summary, let us see the difference between summary and quantile. So summary of pollution, it is giving me minimum, first quartile, median, mean, third quartile, maximum. Okay. So what is quantile giving? Same data it is giving. What it is giving is 0%, this is the minimum, and 100%, this is the maximum. So you can see the first dot is the 0%, last dot is the 100%. Next, first quartile is nothing but 25%, median is nothing but second quartile or 50%, third quartile is 75%, and maximum is 100%. So if you see the difference between quantile and summary, two differences are there. First difference is the precision. Summary is giving up to 3 digits, whereas quantile is giving me up to 6 digits precision. Second thing is that summary is giving me one extra statistic, that is mean, which is not given by quantile. Quantile is not giving me mean statistic when compared to summary. Hope you are able to follow. Any doubts up to here, sir? Hope you are executing. I don't know how many of you. Yes, sir. Is Vijay Lakshmi, Nisha K, Maria, Manjushri, Fabio, Georgie. Are you there, sir? Hello.
Sir, yes, sir. Tell me.
Yeah, are you able to follow?
Sir, I'm not able to hear your voice properly. Once again, can you just tell me?
Yeah, let me-
Hello? Yes, sir, I'm able to follow.
Okay, fine.
Srikanth sir,
Yeah.
can you hear me?
Yes, madam. Yes.
You take a break a bit, okay? You take lunch break and then.
Sir,
No,
please, sir, we need a break, sir.
Okay. Because I want to continue and finish this off and remain break in the again break
Okay,
again.
till what time you want to finish it up, sir?
By 2 o'clock I will finish it off, madam. 2 o'clock.
Okay.
Okay,
Students,
sir.
please cooperate. 2 o'clock you can finish and then leave off, huh? Tomorrow you can join.
Yes, sir. Yes,
Yeah,
sir. Yes, madam. Yes, madam.
that will be fine. Yeah. Okay.
One second, I missed the file.
Sir, you can continue and finish it by 2 o'clock, sir.
Yeah. One second, because
Okay.
entering, I have to remove that lock because it is asking for permission
Okay, sir.
by default. Navneet has entered again. He is frequently going out and coming in. Yes. So this is one thing related to first level of statistics that will give you idea about where you are. How is this useful? This is useful in first filtering out outliers. This box plot along with summary will help you out in figuring out your distribution, whether it is normally distributed, whether it is skewed distribution. If it is normally distributed, then you see a proper spacing between your first quartile, second quartile, third quartile, and the maximum. There will be neat symmetrical spacing if it is normal distribution. If it is biased, then you see median either going above or below. Between these two lines, if median is coming in exactly middle, then it is kind of little normally distributed. Otherwise, it is kind of skewed, in a sense biased towards the one side. So this is how it is helpful. Otherwise, 1 point interquartile range. We take interquartile range and say 1.5 of interquartile range will help us in identifying the outliers plus or minus. That is again not point of concern right now. So this is first thing that we are looking. Next, we have seen the box plot. So I say box plot of the variable. This is the first thing. Second thing, I can use extra arguments like one more thing that I forgot to tell. If I'm doing it in the console, for example, let's say box plot was not there. You see, I have cleared the screen. Now, if I want to access previous comments, I have to use upward arrow. Upward arrow, previous comment I can access. And I can press enter. And I can either press enter, I will be able to access the scene. So let us add color to this. So if I say comma, color, so if I say color equal to blue in double quotes, so this is how I give color to the box plot or any plot. So any plot that I have, COL is for giving colors. So what are the colors that are there? Is it red, blue, green? So there are many colors, 600, somewhere around 600 colors are there. If you type colors function, press enter, you can see there are almost 657 colors are there, and the names, these are the names that you can use. So what we have seen, how to draw a box plot and how to add color to it. Because the color is equal to double quote blue. So when to use double quotes, when not to use double quotes is any text you are trying to supply, you have to use double quotes. Any variable name that you are specifying, you should not be using double quotes. For instance, why string is specified always in all the programs, not just in R. Why a double quotes is used for string or text variable is because if you don't specify, then the program will start looking for any variable that is stored on the computer. Okay. So this is box plot. Next form of next thing that we'll see is histogram. Histogram, plotting histogram, it is hist function. We have hist function, hist pollution dollar PM25. Similar way, let us press Control Enter, and I have got a histogram. And similar way, if I want to add any color, just take comma and say color is equal to green. You have got the color to it. Next thing is called as a rug plot, and this rug is first thing I have to discuss about if I have to explain these different graphical packages, then I have to explain about the graphical systems in R. Majorly 3 graphical systems are there in R. What do you mean by system is what is the difference between graphical package and a graphical system? There are 2 different things. Graphical package is like an app that you install. We have ggplot2, Lattice. These are the packages or the software that I have to install like app on RStudio or R. Package is different, system is different. System, for example, you can take the example of C program is there, C++ is there. And what is a system programming system or a paradigm? System is your C++ is object oriented, C is not object oriented, it is procedural language. So these are the systems and apps. So here also we have graphical packages and graphical systems. If I say ggplot, ggplot2 is the graphical package, ggplot or gg is the system. Grammar of graphics is the system. So first let me explain about graphical systems so that you can appreciate what you can do, what you cannot do. There are 3 systems. Might be I have a slide about them. I don't know. Okay, going to the slide, it will take time. Let me summarize just like that. Okay. There are 3 graphical systems in R. Main popular graphical systems, 3 are there. One is your base graphics. Second is called as Lattice, Lattice. Third one is called as ggplot. What we are using right now is the base graphics. The base graphics is what we are using. You can also use something called as ggplot2 and Lattice package you can install. ggplot2 is the package. Gg is the system, grammar of graphics, or ggplot is the system, grammar of graphics, plotting is the system, and base graphics is the package, and base system you can call it as Lattice package, Lattice system. Now what are these systems and how they are different? Let me discuss about that. See, when we talk about some of the graphical systems are additive in nature. Additive means you can build one after the other, you can keep on building. For example, right now here histogram is there. Yeah, this is an artistic palette kind of system. It is also called as artist palette system. In a sense, what does the artist do? First, he will paint. Then, for example, if I'm painting, first I will paint blue. Then I can paint on the top of blue. I can paint green color on. So by that, what I am doing, two things I am doing. First thing is called as what is artist palette system. I am trying to explain what is artist palette system. Artist palette system is, as an artist does, you paint one color, then on the top of that you can paint another color, and how it is visualized is different. For example, if blue color I am painting and blue is seen, on the top of it is green color I am mixing it, a hue of that will be given. So first thing, artist palette system is about you are able to add to existing things. Next, if you are looking at trellis system, which is lattice system or trellis object. This system doesn't allow adding layers like that. For example, anything that you are writing should be written in one command and that's it, finished. You cannot add anything afterwards. ggplot is a mix of both the systems. That is, it is a mix of base graphics and it is a mix of some good properties from artist palette, some good properties from what I said, lattice package it took and it built upon. That's why it has become very famous. ggplot has become very popular. Not only that, aesthetics is one thing. Second thing, if you are drawing very complex graphics in ggplot, it will be very easy for very complex graphics. If you are drawing very simple graphics, it will seem nonsensical for a beginner. Okay, I will discuss that nuances there. So why I am telling about this is because right now I have drawn a histogram. Because this is base graphic, I can overlay. It is an artist palette system, so that means I can paint on the existing what is it, painting. Right now this is the painting, I can paint on that. That is called as artist palette. But this you can do in base graphics, this you can do in ggplot, but in lattice system you cannot do. So what I'm trying to tell you until now, even if you don't understand it, sir, right now we have a chart. Normally, in other packages, if you draw a chart, that can be final. But here, what you can do, you can still add to this. Start the painting is not over it. You can still add to the painting. So let us look at that. Now, if I ask the question that, let us look at the plot first. Plot is showing pollution level. Most of the cities, what is the pollution level in most of the cities? If I ask what is the pollution level here numbers are there from 0, 5, 10, 15, somewhere around 20, 25, you can see the maximum and all those things. We have seen the summary. So you can imagine the summary here. So you can see starting from 3.38 up to 18.441, we have the pollution levels. And highest pollution, in the sense, most of the cities, the pollution levels in most of the cities are between 9, 10, 11, 12. So most of the cities, the pollution levels are between 9, 10, 11, 12. That's why you are seeing that mean is 9, median is 10. Why? Because most of the data concentrates there. So what does this mean? Most of the cities, the pollution levels are between 9 to 12. Now, this is base graphics is a artist palette system. That means if you cannot visualize density is the concentration of the matter. Here in histogram, the concentration is shown through the height of the graph, height of the bar. If the bar is the highest, that means there the concentration of data points is more. Another way of looking at it is using rug plot. If I say rug, let me. So let me copy this. I say run, press Control Enter. Now, if you observe the difference, you saw small barcode kind of lines. Let me zoom in a little bit so that you can see and I can convince you there is some change that has happened into the graph, though it might not be visible. Yeah. Now hope you are able to see the screen. What does two things rug function has done? Two things it has done. First thing is it did not create a separate histogram again. What it has done is like artist palette, it has added to the existing chart that is already there. What does rug plot do? Rug plot will give you the density of data points in a particular area. In the sense, if you are still not convinced about that most of the data is concentrated between 9 to 12, then you can see at the bottom the rug plot is there, and you can see the densities. It is between 9 and 12. You can see darker regions showing the density. This is what rug plot does. Next thing, let us proceed with histograms. We have done rug plot. Let us do histogram again. But in histogram, let us focus on class intervals. So let us say I want to class intervals is how much divisions you are doing. Class intervals, for example, 0 to 5, 5 to 10, 10 to 15. This is one class interval. Or another class interval could be 0 to 10. I can put one bar of histogram from 0 to 10, 10 to 20, 20 to 30. So how many parts you want to make out of the data? So let me divide this data into 50 parts. 50 break is equal to breaks is equal to 50. Might be it is called breaks. Yeah. So you can see that more the number of breaks I am giving, more the thinner the bar and more the intervals would be. Let us see 100. So the more the cuts I am more, so breaks is like you're cutting into pieces. More the pieces I am cutting of a particular object, the smaller the pieces will be. So here the effect is that the thinner will be the bar size and the height also will be different. Okay. So this is how you control how many bars you want. 100 bars. I have made 100 provisions per bar. If I want only 3 breaks is equal to 3, I have 3 to 4. Okay. So this is about histogram. Next thing is the average line. So let us go back to box plot. We have done box plot already. So let me bring in again box plot for you. I'm copying pasting box plot. So I have told that box plot will show the middle one, the middle line that we are showing. This middle one is, what is the middle one? Middle one is the median. Now let us say you want to show the mean also. Otherwise, you want to show some kind of, for example, let us say here the data is showing that 50% of the cities are below the point of 11 pollution. 11 pollution is the 50% cutoff. But the pollution board also would have given the line. For example, let us say pollution board has given that the pollution should not cross 12. Okay. Let us say PM dollar pollution $25 is there. I am sorting this data sort pollution 25. Sorry, again the same PM 25. Now, right now I have sorted the data in ascending order. So this is the data. So these are the pollution levels. Let us say these are actual pollution levels of the cities. Let us say government has given a standard saying that any city should have its pollution under 12. Now here I want to visualize where exactly is 12 is, because here I cannot see properly the grading. So I want to point out that 12. So if you want to do anything like that, if you want to draw anything like that, then you can use the function called abline, and you can draw a horizontal line. So if I say abline, it will draw a line. H means horizontal line, V means vertical line. So if I say H is equal to 12, what it does is exactly at 12, it will draw a line. And what is the purpose of it? It can be anything. The purpose can be anything. So here you can see approximately, if you are asked that approximately how many cities are under the, how much percentage of the cities are under the pollution control, approximately. We have already seen first is 25, second is 50, third is 75. So approximately by just looking at this, we can say almost 75% of our cities are under pollution control standard. Only 25% or 20%, because this is not exactly here. So we can say approximately 75 to 80%, 75 to 80% are under pollution control of 12, and only 25% are having higher over pollution, and where it is harmful for the citizens. Okay. So this is about heavy line drawing over. So until now, what you are seeing is a basic plotting system where it is an artist palette system where you can on the same graph you can overlay many things. We have seen how to overlay a line over this using tab line. Now next, let us draw another histogram, and let us see how to draw a vertical line. Let us go back using up arrow key. Let us go back to our histogram, original histogram where breaks were not there. Yeah, histogram pollution $PM25 and pollution $PM25. This is the one. Now here I might wish to draw a vertical line, not a horizontal line. So how to draw that? It is the same thing. AB line V is equal to 12. If I want to draw a horizontal line, so I say AB line, vertical line, because this is vertical. If I say V is equal to 12, you can see that there is a small black line that has come. Now we cannot clearly see because of the color and because of the thickness of the line. So to increase thickness, we say line width is equal to, default is 1. So let us say 3. Now you can see a thick line. Now Second thing that we can do is instead of giving number directly, we can also give, for example, I want to draw a line for the mean or the median. So that also we can do. For example, let us change the color here. Let us add the color here. Color is equal to magenta. Now it is because of the contrast, it is more visible right now. Okay. Now let us, instead of adding a 12, I want to add at the median point. Okay. So I can say median. I want to identify where the median point, middle point is. So I say median of pollution dollar PM compare. So now I have got the line exactly in the middle. I have got it. So this is about overlay plot system. Next histogram we have seen. Next is regarding bar plot. So let us look at the bar plot. Before looking at the bar plot, let us go back to looking at the structure of this pollution data. And there are 5 variables that are there. Third variable called region is a character. Region is a character variable. So let us look at region. What does it exactly contain? Pollution dollar region. So you can see most of them is east-west region is there. Okay. How many east and how many west are there? This I want to count. I want to count how many east and how many west are there. This I can do, the frequency count I can do using a command called table command. Table of position dollar region. Press enter. Now I have got east is 442 regions, west is 134. This I can plot it. Now next thing is in R, apart from equal to, you can use arrow marks, left arrow, right arrow. Why, where it can be useful is, right now I have used up arrow key. Now the table, what is given, I want to store in a variable. So I can use dash greater than to store it in a variable called region. REG region, press enter. Now if I type region, it will give me the same data, east 442, west 442. Now I can plot this using bar plot of region. So this is next thing is giving a bar plot for the data, numbers of each region. Now next thing that we can look at is giving the description. Right now it is very bland, so we can put the heading. So how to put the heading? There are different headings that are there. The chart title is called as main. Main is the you can see if I say main, it is putting count of religions there. I can region. Next X label is region in double quotes. Always text should be in double quotes. So now X label it has added. Now Y-axis label YLab. Count of regions. This is YLab. So if you want to add any title to a chart, you say count of regions, main, Main is user chart title, XLab will give you x-axis, YLab will give you y-axis. As we have already told that this is a artist palette system, that means you can add it separately also. For example, this is the bar plot. Now I can use a function called title and say, oh, already chart is done. I'm not drawing the chart again. I'm just adding the title to it. Okay. So this is how I can add to the title later on. But this kind of skill needs you that you are thorough with. If you have read the message that I had given, there are hell lot of ways to do a particular thing. For example, here, how can you add title to a chart? There are different ways to add a title, but ultimately what is happening is adding title only. The second thing is, for example, if you are taking how to assign a value to a variable, there are 5 ways you can use 5 different ways to assign variable value to a variable. Normally in traditional programming, you say x is equal to 5 or x is equal to 6 and variable is assigned. There are no other ways x is equal to that. But here you have 5 different ways of 5 different ways. Apart from equal to, you can use left assignment operator, right assignment, global left, global right assignment operator to assign. Why I am telling you this is because I have, as I have noted in my letter, that if you are initially, for example, I had a programming background. Once I came to R, I really hated it for some time. In the sense that why for doing a single task, why they are having so many different methods. For example, assigning or finding a mean. Why can't they have just one method and do everything? So it seems the ultimate answer to why it is like that is lazy programming. In the sense that if you understand the word, I will not explain what lazy programming is. Lazy, it is made for a lazy programmer also. That's how I can say a simple way of putting it. And some of them, genuinely, you have to, there is some serious problem. For example, if I say x is equal to 5, assignment operator, and x, right assignment operator, left assignment operator. If you are using x is equal to 5 and do not know our program thoroughly, then if you are using at the production level, at your workplace, in some places, the assignment operator equal to will be a serious problem. There is a flaw. When conflict arises, equal to cannot handle it. It is a flaw, seriously. If you are learning advanced art, we can discuss about memory allocation and the concept, but right now it will be overwhelming. There is a serious flaw in equal to assignment operator. So it is a what I can say is R is a combination of because why this has come is R is a software that is built on earlier software called S. S was the software that is already there. So it is just it has remodeled the software and it is using. So that is the main problem. Problem in the sense that I cannot say problem. It is what it is. That has given rise to certain weaknesses in the system, because whatever the weakness of S is there, it has been carried on instead of sticking or things. Some of them are structural issues which are carried on. So that is for the advanced programmer, and we are not talking about serious R programming right now. We are just looking around from a research perspective, from a beginner perspective, how to look at the data and how to get descriptive statistics on the data that you have, and how to get basic visualizations out. That is what our aim is right now when we are looking at a big exploratory level. But let me tell you that most of the times we use visuals only for descriptive, but you can, as I was shown, you can use for showing causality. Even for hypothesis testing also, you can draw charts for hypothesis testing also. So hypothesis testing in R, you will find a lot of tutorials online on offline how to do hypothesis testing, like TJS test. How can you use? Because I want to promote the habit of using Visual CM for hypothesis testing also. Uh, that is right now. Let us get back to the point, and we have. Get back to the point. Now, so we have seen a simple summary of data. For example, using the numerical summary, we have seen if you want a numerical 5-number summary, you can use summary. Otherwise, you can use graphical summaries. Graphical summaries are you have seen graphical summaries, box plot, histogram with rugs, histogram with breaks, histogram with outline. You have seen. Then you have seen bar plot. Next, because we have started with a box plot and histogram. Okay, this is a hell will not be able to. Okay, I'll end with what is it? Because we have discussed about box plot initially. I have shown how to use how to get a single box plot. Now how, and I have told first principle is wherever possible do a comparison. I have given this because sometimes why you have to do comparison, because comparison will give you interesting insights and additional points to discuss. Sometimes comparison will give you the causality effect, and sometimes comparison will help you overcome something called as Simpson paradox. These are the 3 reasons that I have appealed to use multivariate data and multiple charts, comparative charts. So single bar plot we have done. How to do comparative charts? We'll end with the comparative chart, comparative box plot, and comparative histograms. And scatter plot, it will take time. Well, I have to end at 2 o'clock as I promised. So let me do with the comparative box plots and comparative histogram, and we'll finish that off. So how to do multiple box plots or comparative box plots. So let us go back and let us see how to draw a basic box plot. So if I say box plot of pollution dollar PM25, which is a continuous variable, and I have a box plot. Now, if I look at, for example, the pollution data, I have region, 2 regions are there, east and west. If I want to compare east region pollution distribution with west region pollution distribution, trying to judge whether east region pollution is higher or west region pollution is higher, I have to compare east and west region box plots. When I have to do this, I have to use a method called as formula method. You have to understand what is formula method. Formula method is syntax. Formula method syntax. Formula method syntax is y tilde x, where y is the independent dependent variable. Y is the dependent variable, x is the independent variable. Now, how can I use this syntax in box plot? Is go with normal box plot. Now the formula is y tilde x. Now, when I say what is independent and dependent, pollution levels are dependent on region. Region is a independent variable. Pollution levels are dependent on region, and region is a categorical variable. Pollution is a non-categorical or numerical or ratio level data. So when I have to do that, y tilde x, here y is the dependent variable, pollution, region is the independent variable, east west. So pollution levels depend on whether it is a east region or west region. For example, we say North India has more polluted cities than South India. Okay, why? Because more industries are there in North India, so on and so forth. Right now, we'll not get into details and break our text. So ultimately, we have this formula method that we are doing. Whenever you are using formula method goes like this. Y, independent variable. Here it is PM25 solution is the dependent variable. It is dependent on the region. Now here if you see, I am not using solution $PM25. I am using directly PM25. So to compensate for that, I say data is equal to solution. Why I am doing this? Because in the formula method, I don't specify every time solution dollar. In the formula method, I just specify the variables and I say data is equal to solution. Now now you have got comparative box plot. You have got comparative box plot. Now, first principle, we have covered the first principle in practice, comparative box plot. Now, in comparative box plot, let us end this session by answering a question. What question can this comparative box plot answer? You can answer the question whether the average pollution of cities across east or west. Which one is highly polluted region, east region or west region? If you answer this, we are done with it.